Lesson 1-3, greatest common factor. So in this lesson, we're going to find the greatest common factor of two or more numbers. We're also going to simplify fractions using the greatest common factor. We're also going to write equivalent fractions, and we're going to write decimals in fractional form. So first, let's go through some vocabulary. The greatest common factor, or the GCF, just means the largest factor numbers have in common. Prime factorization is a process that you can use to break down a number using just prime factors. Now, a prime number is just a number that has exactly two factors. So a couple prime numbers would be 2, 3, 5, 7. Those are the main ones that you're going to use most often when you're prime factorizing a number. And then the simplest form is just another way of saying putting a fraction in lowest terms. So a fraction that cannot be broken down any further would be considered lowest terms. And the greatest common factor of the numerator and the denominator is going to be 1. They have nothing else in common to break it down any further. So Mary has 45 feet of rope and Peter has 60 feet. What is the longest length they can cut from each rope so that all the pieces are equal in length? I'm going to show you two methods you can use to help find the greatest common factor. So the first method would be using prime factorization. So if I take 45, let's do that over here. So I got 45, and I'm only going to use prime factors. Again, numbers I want to use are like 2, 3, 5, and 7. I could use more, but those are the main ones I'm going to use. So I know that this could be 9 and 5. I know there's a 5 there, times, and 9 can be broken down as 3 and 3. And then if I took 60, and I use prime numbers, I know 2 is going to be a prime number that can divide into 60 evenly, and that gives me 30. I can do 2 again, and that's going to give me 30 divided by 2 is 15. Then we're going to have a 3 and a 5. So 4 times 15 gives you 60. Now I want you to look at what we have here. We're going to circle what we have in common. So I see a 5 here in both numbers, so prime number of 5, and then I have a 3 in both of them. So if I multiply those, 5 times 3, the greatest common factor would be 15. If you were using repeated division, it would just be, we could just draw a table here. So here we have 45, here we have 60, and we're going to divide by prime numbers. So I'm going to divide everything by 3, and you get 15 here. You get 20 here. And then a prime number I could divide those out would be 5. 15 divided by 5 is 3. 20 divided by 5 is 4. I can't divide any of those by a prime number anymore. So now I just look at the two numbers on the side here that I divided, and I just multiply those numbers, and I get 15. So simple problem A, find the greatest common factor of 12 and 56. Now, are these the only two methods you can use? No, you can use other methods as well. You could actually write out all the factors of them if you want to. It's like for this one, let's do 12 and 56. So if I did all the factors of 12, factors of 12 would be 2 times 2, which is 4, and 4 times 3 is 12. 56, I can do 56 divided by 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. So if this is 8, I know that 8 times 7 is 56, and 7 is a prime number. So now if I look at what they have in common, they each have a 2, and they each have a second 2. 2 times 2 is 4, so the greatest common factor of both of them would be 4. Next, 24, 72, and 144. So let's do 24. I know that 2 can go in it evenly, so half of 24 is 12. I can divide 12 in half and I get 6. Half of 6 is 3. So 4 times 6 is 24, so that part is done. 72. I can divide that in half and I get 36. Divide the 36 in half and I get 18. Divide the 18 in half and I get 9. And then 9 is 3 times 3. And then we have the 144. Well, I know 144 is 12 times 12. And I know that 12 is 4 times 3. So I would have a 2 times a 3. Actually, 2 times 2 times 3. Let me put it that way. So 2 times 2, there's your 4 times 3 is a 12. And then I have a second group, 2 times 2 times 3. So there's my 12 times 12, which is 144. Now, if I look at all of them, I see that they each have this 2. They each have this 2. They have this 2. And they also all have a 3 involved. So now if you look at them, I have a 2 times a 2 times a 2 times a 3. Well, 2 times 2 is 4, 2 times 3 is 6, 4 times 6 is 24, so the greatest common factor amongst them would be 24. Next, we're writing them in the fractions in simplest form using the greatest common factor, or you can use prime factors to simplify. So here, if I were to rewrite 16, this would be, I know this is 4 times 4, and I know 96 would be 4 times 96 divided by 4, that would give us 24. And then I know I can do this as 4 times 1, and this would be, sorry, no, let me divide this the 4s out. So now you're at 4 and 24. And I can be, this is 4 and 6. The 4s divide out, and you're left with an answer of 1/6. It would be a negative 1 out of 6. Now, if I were to do it like the just prime factors, so if I did it a little bit differently, I could do 16 would be 2 times 2 times 2 times 2. And 96 would be 2 times, so half of 96 would give us 48. And half of 48 would give you 24. And half of 24 is 12. And half of 12 is 6. And half of 6 is 3. So here's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 3 is 96. Now, if I look at what I have up here, this 2 divides out, this 2 divides out, this 2 divides out, this 2 divides out. I'm left 1 on top and 3 times 2 on the bottom, which is your 6. Next one here, I got 24 and 144. Well, I know this is 2 times 12. And I know this 144 is 12 times 12. So now the 12s divide out, and now you're left with 2 over 12, which I know I can write this as 2 times 1, and this would be 2 times 6. The 2's divide out, and you're left with a positive 1/6. Sample B, we're going to use either the greatest common factor or prime factors to simplify. So what I was doing, you'll notice what I was doing before was just using prime factorization, doing that. So here, I'm going to do this one a little bit different. I'm going to use the greatest common factor. So if I think the biggest number I can divide out of 14 and 42, So it would actually be 1 and 14 on top, and the bottom would be 14 and 3, because 14 times 3 would give you 42. The 14s divide out, and you're left with, don't forget this negative here, a negative 1/3. Now, if that one's a little bit harder for you, then I would have 2 times 7 on top, and here I would have 2 times 3, that's my 6, and then 2 times, then I would just have my 7 here, because 6 times 7 is 42. Now if I look at here, the 7s divide out, the 2s divide out, I'm left with a 1 on top and a 3 in the bottom, so there's my negative 1/3. This next one, 27, I would do 3 times 9, and down here I could do a 3, and that would be a 3 times 42. So I know that the 3's divide out, and then I can now write this as 3 times 3, and I know that 42 would be 2 times 3 times 7. And from that point, the 3's divide out, and you're left with 3 on top and 14 on the bottom. So our answer would be 3/14. Moving on to the next part is writing equivalent fractions. Equivalent fractions mean they have the same value, but they're in different forms. Or not, I shouldn't say different forms. Your numerator and denominator might be bigger or smaller. So it doesn't matter if you make them bigger or smaller, they still have the same value. So an example is 1/2 is the same as 2/4, which is the same as 3/6 and 4/8 and so forth. So here we're going to multiply the numerator and denominator by the same number. So if I want to write an equivalent fraction, so if I multiply this top by 2/2, I'm now left with 18 over 30. And 18 over 30 would still give me 9/15. Now, if I were to divide, I could actually divide that, and I'll show you on this next one here, divide this. So if I divide the top and the bottom by 3 over 3, I would be left with 3 over 5. And 3/5, so if I did 3 times 6, that gives me 18. 5 times 6 gives me 30. So 3/5 is the same as 18/30, which is the same as 9/15. Now the other one, we're going to find out what n is. And in order to do that, there's a couple ways you can do this. You could do cross multiplication and dividing. This one I would just do, I know 9 times 4 gives me 36. That means 7 times 4 would give me the n, which that would give us n equaling 28. And this one, I know that 56 divided by 8 is 7. That means 128 divided by 8 would give us, and let's just grab our calculators quickly here, and we'll do 128. And we're going to divide that by 8. And that gives us 16. So n would give us 16. Sample problem C, we're going to write equivalent fractions or solve for the variable here. So for this one, I want to write an equivalent fraction for those. So I'm going to make this bigger. So I'm going to multiply this by 2. 81 times 2 is 162. And 144 times 2 would give us 288. So that is one way you can rewrite an equivalent fraction. Now, could I do something a little bit differently? Could I make it smaller? Yes. But this one I figured it'd just be easy enough for just to multiply everything by 2. So 9/10, make that bigger. I would still multiply that by 2 over 2. And that would give us 18 over 20. And these other two, we're just finding out what n would be. So I know that 64 divided by 4 is going to give me 16. But I can't do 18 divided by 4, so let's do a different way. So let's show another way of doing this. So let's cross multiply. So if we did 18 here, let me try something else different. Let's simplify this first fraction here. So if I divide these by 2, that's going to give us 9 over 32. And this is going to equal n over 16. So now, if I divide this by 2, it gives me 16. And then 9 divided by 2 is going to give me n. That means n would have to be 4.5 or 4.5. And this next one, here I don't have the variable is missing here, so let's just make this an n right here. So if I did 125 and divide that by 5, I should get 125. And 95 divided by 5 would give you your n, and n would have to be your 19, because like 5 times 9 would be 45. Put the 5 down. 5 times 1 is 5 plus 4 is 19, or no, 95. So for this one, n would give you 19. Next, we're dealing with terminating decimals. So that means these are decimals that end. It says write a terminating decimal as fractions by writing all the digits after the decimal point in the numerator and the place value of the farthest left digit as the denominator, and simplify from there. So here I have a negative. So I'm going to take my 35, that's my numerator, and I have 2 decimal places here. So that means I'm at 35 hundredths. So now I have my fraction here, and all I have to do is just reduce this. I'm going to divide both the top and the bottom by 5. And that's going to give me negative 35 divided by 5 is negative 7. And 100 divided by 5 is 20. So my answer would be negative 7/20. Now this next one, I have a 6 as my whole number. So I'm going to have a mixed number here. And my numerator is going to be 8. And this is 1,000. And for this one, I'm just going to keep the 6 there, but I'm going to reduce the fractional part. So I'm going to divide this by, let's divide this by 4. And this is going to give us 6 and 2, and then 1,000 divided by 4. So let's just get our calculators just to verify. 1,000 divided by 4 gives us 250. So here we got 250 here. And we can reduce this by dividing this by 2. So our answer would be 6 and 1 over 125. And our last ones, simplify the following here. We're going to do the same thing. So this is negative 55. It's 2 decimal places, so that's 100. So 55 hundredths. So if I divide the top and bottom by 5 over 5, I'm left with negative 11 divided by 20. And I can simplify that further. 1 and 36 hundredths, so this is 1 and then 36 over 100. Simplify this, I'm going to divide this by 4 fourths. So I'm going to still have my 1. 36 divided by 4 is 9. 100 divided by 4 is 25. So my answer would be 1 and 9 over 25. And our very last one, we have a negative 2, and then it's 6 over 100. Divide the top and bottom by 2. So this is going to give us a -2. And then that's going to give us 3, not 6, it gives us 3. And 100 divided by 2 is 50. So -2 and 3/50. So that is our lesson on greatest common factor.